In this video we are going to talk about weight and mass and apparent weight. So if you have some mass released in air like this, the only force acting on this mass is the weight, the gravitational pull of the earth, provided that air resistance is not taken into consideration. So according to Newton's second law, the resultant force acting on a mass is given by mass times acceleration. This time the force is the gravitational pull. The gravitational pull of the object, the gravitational pull of Earth on the object, meaning that is its weight. And the acceleration, the acceleration is g, acceleration due to gravity, and the mass is the same here and there. Now, when you substitute instead of the force resultant the weight, and instead of the acceleration g, the acceleration due to gravity, you get the force. Instead of the force, weight is equal to the mass times, instead of the acceleration, g. So this weight is equal to mass times acceleration is due to Newton's second law. This equation is due to Newton's second law of motion. Yeah. Now, what if the system is not stationary? What if the mass is accelerating? So you can consider an elevator. An elevator is a vertically accelerating system. So the weight of some object in a vertically accelerating system is apparent weight. Apparent weight. So the apparent weight is very simply given. WAP is equal to the weight, the mass times the acceleration due to gravity plus or minus the acceleration of the elevator. So you add when the elevator is accelerating upward, when the acceleration is upward, and u minus when the acceleration is downward. And if the acceleration is zero, it can be constant velocity, upward or downward. So if the acceleration is zero, the apparent weight, the weight apparent, is equal to the mass into g plus 0, which is the mass times gravity, is the true weight, the weight of the object in an accelerating system. Let's do some examples on this. Now the question says, what would be the weight of 12 kilogram, okay? 12 kilogram object in an elevator if the elevator is accelerating at a constant rate of 6 meters per second square up. B, if the elevator is accelerating at a constant rate of 6 meters per second downward. This is C again. If the elevator is not accelerating, the elevator is moving with a constant velocity of 10 meters per second up. Let's dive in. The true weight, the apparent weight is given by the weight apparent is given by the mass into the acceleration due to gravity plus or minus the acceleration of the system. So in the case of B, then the elevator is accelerating upward. So there is a weight here, there is a measuring instrument here. So the acceleration is 6 meters per second square, and it is up. So we add, up is added. So the weight apparent in this case, in the case of A, is equal to the mass is 12 kilogram and gravity is 10 meters per second square. Then you just plus, because upward is plus 6 meters per second. 6 meters per second square. So this gives you 12 times 6 plus 10 is 16. So kilogram from mass times meter per second square. So this is equal to 12 times 16 times kilogram dot meter per second square. The product is 192 kilogram. Meter per second is Newton. So this is the weight when it is measured in vertically accelerating system. If the elevator is not accelerating, the weight is supposed to be only mass times gravity, which is 10 times gravity 10, the mass is 10 again. Then the elevator, due to the acceleration of the elevator, the mass is increasing. B says, according to B, so we are looking for again the weight apparent now. Okay, the weight apparent is required. So we have the mass is 12 kilogram, and the gravity is 10 meters per second squared, and the acceleration of the elevator this time is, here is the elevator, there is a mass in the elevator, and it is accelerating down at an acceleration of 6 meters per second squared. Now, so the acceleration is 6 meters per second squared, and it is down. Okay, now let's proceed. The formula for the weight apparent is always weight apparent is equal to the mass into the acceleration due to gravity plus or minus the acceleration of the system. So this time it is down, so you minus, so this is equal to the mass times gravity minus the acceleration of the elevator. So this is equal to 12 kilogram times kg times the mass, the gravity is, so we do 10 minus 6 meter per second square. So this gonna give us 12 times 4. All right, so kilogram dot meter per second. So this is equal to 48 Newton. So the weight is mass times gravity in air or in an accelerating system. That's a true weight, which is 12 times 10, it was 120 Newton when it is in an accelerating system. But if the elevator, if the mass is in vertically accelerating system and the acceleration is upward, the weight of that object is from 120, it comes to 192, meaning as you accelerate upward from the earth, away from the earth, your weight is increasing. And if the elevator is moving downward, so you do, at the beginning your weight in an accelerating system was 120 Newton, but now you are in accelerating downward, so the mass is 12 kilogram times 10 minus 6 is, so you get 48 Newton, meaning when you accelerate downward, so your weight apparent is smaller than your true weight, your weight in air. Now note a point. Here the point is, if your acceleration is the same as g, then what would be the weight apparent? The weight apparent is gonna be the mass times the g minus the acceleration, but the g and the a are equal, so this is gonna be the mass times 0, so you're gonna have 0 Newton weight, meaning when a is equal to g downward, so you fall freely, so when you fall freely, you are apparently weightless. Okay, you are apparently weightless. So apparent weightlessness is happen when you fall freely. Now the third question says C, so we are given the mass is 12 kilogram and the gravity is 10 meters per second square, and it says the elevator now is accelerating. Not accelerating, the velocity is constant. It is constant and it is upward and it is some number, any non-zero number, right? No matter how much the velocity is, because your weight is not dependent on the velocity. It's 10 meters per second, so 10 meters per second. Then what is your weight now? If the velocity is constant, your velocity is constant and it's upward, and your acceleration gonna be 0, then the definition gives you the weight apparent is equal to the mass times the g minus is upward. It's gonna be plus, of course, plus a. So this is gonna give you the mass is 12 kg times 10 plus the acceleration is 0. So this is gonna give you 120 Newton. So if you are in an accelerating system, your weight is true weight. So this time when your acceleration is 0, your weight true and your apparent weight is the same, and this is mass times gravity. Thank you for